Okay, so hi guys. Uh, I'm going to start recording these solutions for you guys. So recently, I took 6 AP exams this year. Well, I still have my sixth one right now. It's physics one. On the last day, but I'm going to share my solutions to all the APs that I did take. So I'm going to start off with Calc BC, but I know it says AB here because I half of the FRQs here are shared with AB. So I'm ended up going to have to do the other half of the AB ones, and you'll see all of those being uploaded within the next 24 hours. So the first FRQ here is in the calculator section. So we were allowed to use decimals on the test, so I'll have some use of it here. I know I use my own graphing calculator on the test, but that's fine. I can do all the calculations here. But so in the first free response question on the test, we were presented with an invasive species. So College Board seems to like to put invasive species on the test. We did see one on the stats exam, but I'm going to cover that later. So part A is asking us to have the average number of acres. So when we analyze these functions, we know that C of t represents the number of acres affected by the invasive species. C prime of t would then represent the rate of change of the number of acres by invasive species um, per week, since t is given in weeks. So we know that the average value of a function is equal to this. We have the integral from a to b, in this case 0 to 4, of c of t dt. So I'm just going to define this c of t equals 76 arctan divided into t. So this is our c function, and then we plug this in here, and this is the total value of the area under the curve here from 0 to 4. So I'm going to visualize it here. So these are your bounds that you're working with, and it's the area basically under here in this region that we're finding. But because we need an average value, we need to divide by this by 4 minus 0, because that, which would then be 4, because you would need for 4 weeks. So you had like this many acres affected in the 4 weeks, which would average out to 2.778 acres per week. So I just have it here. So that's part A. Part B is asking us for the instantaneous rate of change is equal to the average rate of change. So there's a special existence theorem called the mean value theorem. There, for a function that is continuous on the interval, closed interval, a comma b, and differentiable on the open interval a comma b, there must exist a point c on the open interval a comma b such that f prime of c equals f of b, f of b minus f of a over b minus a. So that's the average rate of change. So basically, this problem is asking us to determine the point that satisfies the conclusion of the MBT on this differentiable function, since we know the derivative is defined here and there's no hole here or anything. This is defined for all real numbers. So our thing here is we're going to plug in first we're going to find the average rate of change. So error equals C of 4 minus C of 0. And I'm going to group this just to be clear over 4 minus 0. So here I'm going to do C of 4 all over 4 minus 0. So our average rate of change is equal to 1.48282. And acres per week. No, and the average value would just be acres. Then you're going to change the units here just to be consistent. And then we need the instantaneous rate of change. So C prime of t equals 38 over 25 plus t squared equals 1.282. So we're going to plot this in the Desmos equation solver. So we got a line here. We're going to take the positive solution here. So we're going to need a positive solution because we have a time interval 0 to t to 4. Yeah. And then we're going to need y equals 1.282. And then Desmos will give us a point here to do. And we see we go use the point from here 2.154 because we need the x value or the t value. So we would say t equals 2.154 weeks. And this is our part B answer. Part C. So we are assuming continuity of this derivative model past 4 weeks now. And as we put it back here, C prime of t equals 38 over 25 plus t squared. We need to write a limit expression for n behavior. And this would equal the limit at infinity. So the limit expression equals the limit as t, which is infinity, of c prime of t. And that would equal to limit as t, which is infinity, of 38 over 25 plus t squared. So this would equal 38 over 25 plus infinity squared, which would be 38 over infinity squared. So this would effectively, because there's an infinity denominator, be equal to 0. All right, the last part of this is our classic Fundamental Theorem of Calculus question that SolidWorld always likes to ask. So we have part D. We're given a new function. A of t is equals to c of t minus this integral function. We're going to go from 4 to t of 0.1 ln x dx. So when we differentiate, so we need to see when its maximum value. So a attains its maximum value when a prime, its rate of change, changes from a positive to a negative value. We know this, it's a way of analyzing functions that we've always done. We should be familiar with this. So first we need to find a prime of t. So firstly, differentiate c of t to get c prime of t for this part. And then we're going to use the fundamental theorem of calculus to differentiate this part. So this would just become 0.1 ln t and remove differential. So let's put a note here about fundamental theorem of calculus. So let's plug this in and see when it equals 0. So let's actually just graph this on our calculator. We have minus here. And we're going to have to zoom out. And we're going to see when this equals 0. So I'm going to put a y equals 0 here. And let's zoom in here a bit, because that's where we'll see our point here, where it equals 0. And there we go, it's 11.417 here on decimals. So we're going to set this equal to 0. And then 11.442 weeks. And it does indeed change from positive to negative based when we see here. It's above 0 all the way here and below 0 here. So we can confirm this. So I'm going to zoom out a bit and you'll be able to see the entire answer here. And just confirm. So that was the first question. Expect all the other solutions soon. Thanks for watching and be sure to support my channel.